We coach engineering students and working professionals for better career opportunities. In this section, we'll learn about cooling load calculation manually. So without further ado, let's start. After the end of this section, you would be able to understand different types of cooling loads. We'll also learn to find overall heat transmission coefficient and CLTD values. Then finally, you will learn to calculate external cooling loads and internal cooling loads. Any building or facility is exposed to heating in most months of the year. To remove this heat, HVAC system performs the function of cooling. The source of this heat can be broadly classified in two categories: the external and the internal. When the source of the heat introduced into the conditioned space lies outside the conditioned space, this is known as external source of heat. Whereas if the source of heat is present within the conditioned space, this source of heat is known as internal source of heat. The cooling required to remove the external source of heat is known as external cooling load, and the cooling load required to remove the heat generated due to internal reasons is known as internal cooling load. The primary reason of heating in any conditioned space is due to the radiation from the sun. When radiation from the sun falls on a building structure, a part of this heat goes into the conditioned space through glass, ventilation, and cracks, and instantly starts heating the conditioned space. So this heat is supposed to be removed instantly, and they become a part of cooling load without any delay. Another part of this heat is absorbed in the exterior walls of the building, and they are introduced into the conditioned space after a short delay of time through the process of conduction. So this heat becomes a part of cooling load after a short delay of time. The conditioned space does not receive the radiation from the sun directly. The heat from building components is transferred to the conditioned space. So the cooling load for the conditioned space is calculated separately for each of these components. First, we'll try to understand the components which leads to the transmission of heat into the conditioned space. This is a 3D plan of a building structure. The exterior of this building is considered as walls because they are directly exposed to sun. When heat from the sun falls into the wall, they do not flow into the conditioned space directly, but heat is absorbed in these walls, and through the process of conduction, heat travels into the conditioned space after a short delay of time. Once the heat reaches the conditioned space, now this is supposed to be removed by the HVAC system. So the exterior structure which is exposed directly to the sun is considered as wall. There can be many other walls inside the building structure. Because they are not directly exposed to the sun, we call them as partitions. If we talk about the cooling of this bedroom, from this wall, heat flows because this side of the wall has a bathroom attached to it, which is not conditioned. So it is possible that heat flows from this side of the wall into the bedroom. Because this wall is not directly exposed to sun, so we are not calling it as wall, but we are calling it as partition. It is also possible that the radiation reaches inside of the conditioned space through the glass of the windows. Now the heat entering into the system can be divided into two parts. One that flows directly through the glass and becomes a part of cooling load, and another part of heat is absorbed by the glass, and through the process of conduction, heat flows through the glass and becomes a part of cooling load of the conditioned space. This is the elevation of a building. Let's say we are doing cooling load calculation for this floor of the building. It is possible that heat flows into this conditioned space from the floor above it. This is known as ceiling. Heat flows in this case through the process of conduction. It is also possible that heat flows from the floor below it. This is known as floor, and the mode of heat transfer is conduction. But if we are doing the cooling load calculation of the topmost floor, the heat flows from the floor above it, which is directly exposed to sun. In this case, it is known as roof and not ceiling. Again, heat can also flow from the floor below it. This is called conduction through floor. Heat can also flow into a conditioned space through the process of infiltration. Now we'll understand the meaning of this term. Let's say there is a window. Due to the clearance, gaps are always present. Air from outside can flow through this gap into the conditioned space. It is also possible that the gaps between the frame of the window and wall allows the entry of air. So the process of unwanted introduction of outside air into the conditioned space is known as filtration. Because this is an outside air, so it will be warm. So this will cause generation of heat into the conditioned space, which is supposed to be removed by the HVAC system. Now we'll learn about the internal factors responsible for the generation of heat inside the room. There can be people doing intense activities like running, dancing, and so on. This causes a generation of heat inside the room. There can also be less intense activities like attending conferences, meeting, attending classes, and so on. This leads to a lesser generation of heat. You can also be chilling out with your friends. Even this causes production of heat. So any activity like sitting, sleeping, dancing, walking, or even breathing causes the production of heat within the conditioned space. The source of all these types of heat generation are the people inside the room. So load calculation due to the heat production by the people is also considered while calculating cooling load. Inside the conditioned space, there can be lighting. These lights produces heat energy along with light. This heat is also required to be cooled by the HVAC system. So they are also considered as a part of cooling load. There can also be appliances inside the conditioned space like refrigerator, oven, printer, coffee maker, and so on. These appliances, when function, produces heat more or less. Because all these sources of heat generation lies inside the conditioned space, the heat generated due to all of these is known as internal heat, and the cooling required to remove this heat is known as internal cooling load.